All right, so I thought I would put together this little video explaining the hint for problem 2 on this week's homework. Ironically, with the problem, the fact that the problem utilizes cables that are of the same material actually makes the problem easier than if they were two different materials. But because it's unfamiliar, you might have a harder time with it, and I'll sort of explain through this hint. So to start, we have a rigid bar that's being subjected to a load P that's pulling downward, and that load's being resisted upwards by 3 cables. And I've called the outer cables A, and then the inner cable, I've called that B. Now, real quick, there are 2 outer cables, calling those the A cables, and the inner cables, calling it the B cable. The outer cables, for instance, are 1/2-inch diameter cables, but you can't just say pi over 4d squared to get the area of that cable, because if you look here at this image to the right, this image here, this is just sort of me sketching it out, but a cable is not a solid bar. It is a series of wires threaded together. So the area of a cable is going to be somewhat less than the solid bar segment, so you'll have to look that area up. Okay. Now, in terms of what's going on with the problem, I thought I would visually or verbally and kind of visually explain what's happening. So I decided to split everything up into 2 stages to try and make it simple. So to start off with stage 1, if you go through the problem statement, the way the problem reads with stage 1 is the system is initially subjected to a load of 12 kips, and the way the problem reads, each individual bar is loaded equally. So if I wanted to express the force in bar 1 or bar A and the force in bar B, the P sub A and P sub B, I'd say that was 4 kips. So at stage 1, at the very beginning, each bar is equally loaded. So each bar contains 4 kips. Okay, that's stage 1. Stage 2 states that an additional 9 kips is placed on the system. Now, we technically don't know how much goes to each bar. I mean, you would think that that would be 3, 3, and 3, but it's not necessarily so. And this is where I sort of fault the author for the description of the problem. What I think would have been nice is in the problem statement the term all cables are assumed to deflect equally under the 9 kip load probably would have clarified a lot of the headaches with this issue. But anyways, going back to the problem, so an additional 9 kips is placed on the system, and we don't know how much goes into each cable, but we do know that the sum of all of these forces in the cables, PA plus BB plus PA, that the sum of all these must equal 9 kips. So that's what's going on right here, that 2 times PA plus PB has to equal 9 kips at that second stage where we're putting that additional 9 kips on there. Okay? Now, we know the total load in the system. We can also determine the total area. Just take 2 times the area of the A cables and an area of a B cable. Now you do the math, that'll come out to be 0.506 square inches. So the nice thing about this problem is that if I know the total load and I know the total area, I can determine the total stress during stage 2. And the nice thing about this is that the stress will be equal in each rod. And that's actually what makes this problem a little simpler. Ironically, if, for instance, cable B was a steel cable and the 2 outer cables were, say, copper, that actually would have made the problem more involved, but I think it also would have made the problem easier for you all in this course, since that would essentially turn this into a composite problem, and it's just like one of the examples that we did in class. Okay, so once you determine the stress in the system, so the stress would be equal in each rod, you can determine the load in each rod pretty easily, just the stress times the area. So this would be the load in bar A and bar B, or cable A and cable B, I should say, under stage 2 loading. So if I wanted to sum that for stage 1, I could get the total load in bar A and the total load in bar B, for stage 1 and stage 2. And that would just be 4 kips for stage 1 on both A and B, and then the stress times the area. Once I get the load in cable A and the load in cable B, I can then go determine, well, what's the percentage? Because I know the total force, when it's all said and done, should be 21 kips. The 12 kips from stage A, or stage 1, and the 9 kips from stage 2. So 21 kips in total, and then I can determine if 21 is the total load, I can figure out how much load's in A and how much load's in B, and from there I can determine the percentage of load in A, the percentage of load in B, the stress in A and the stress in B when it's all said and done and everything's complete. I hope this hint clarified the problem a little bit. If you have any questions, of course, you're more than welcome to stop by my office and we can discuss it. All right, and that's all.